Hello everyone and welcome back to CSEN701 Embedded Systems Architecture, also referred to as Real-Time Embedded Systems. As you all know, we started the third chapter in our course, and this is the final chapter, which is the Communication Buses chapter and how do multiple embedded systems communicate with each other. In the previous tutorial, we discussed the UART communication bus, which is a hardware implementation bus. So it is actually a hardware component present inside our microcontroller, and it is based on the serial communication paradigm. So it actually sends data bit by bit serially. However, it is not defined from a software level, rather it is defined from a hardware level. It's actually a physical circuit or a hardware inside our microcontroller. There is a component called UART inside our microcontroller. Okay, today in tutorial 9, we will be discussing the I2C serial communication bus, which is a serial communication protocol. So it is defined from a software level, not a hardware level. So actually I2C is different from UART. I2C is defined from a software level. However, UART is defined from a hardware level. UART is a hardware component. However, I2C is a software protocol. Okay. So let's start with a quick introduction about the I2C serial communication protocol, sometimes stylized as I2C, as you can see from the official logo. However, you must watch the lecture before solving the practice assignment questions, because the lecture will give you the full implementation details of the I2C bus and what are the different elements present in the data frames being transmitted on the I2C bus. So the bigger picture is actually presented or shown in the lecture. However, here in this tutorial, we will give you a quick recap in order to solve the specific tutorial questions. So let's start with an overview about the I2C bus. As I told you before, it is a serial communication protocol, so data is transferred bit by bit. And as you can see here, we have two lines. We have the SDA line and we have the SCL line. SDA stands for serial data and SCL stands for serial clock. And since here we have a serial clock line or an SCL line, this means what? That the I2C is synchronous. The output of bits is synchronized. Synchronized according to what? According to the clock, which is actually being transferred or transmitted on the SCL line. So actually I2C is composed of two lines, the serial data line where the data is being transmitted on, and the serial clock line, the SCL line, where the clock is being transmitted on. Okay, data on SDA, clock on SCL. And as you can see here, we have multiple embedded systems connected to the I2C bus. However, here we have, or we use the master-slave approach. Okay, we have masters on the bus and slaves on the bus. We could have multiple masters and we could have multiple slaves. And a master can be connected to a single slave or can have multiple slaves connected to it. Okay, so actually, as you can see here from the terminology, master is definitely the one which initiates the communication. The master may actually want to transmit data to a slave or request data or receive data from a slave. So the master is in control of the bus, and the master is the one which actually controls also the clock line, the serial clock line. Okay, the master is in full control of the serial clock line, and the master is the one which initiates the request whether the master wants to send data on the bus or wants a slave to receive, or wants actually to receive data from a slave. That's why this falls under the master-slave approach, because masters are in control and we can have multiple masters, and actually slaves are connected to masters, and a master can have one slave or more slaves. Okay, so let's move on to our first question, and these are just general information questions. So actually, what does I2C stand for? It stands for inter-integrated circuit. Therefore, it is sometimes stylized as I2C because it is IIC. We have two I's, so actually it is I2C or I2C. What company developed I2C? It is Philips Semiconductor, which is known today as NXP Semiconductors, and it is one of the leading companies in the semiconductors field or industry. And actually, this general information you may need to know if you work in the embedded systems field, that actually the I2C bus is actually known as the inter-integrated circuit, and the NXP Semiconductors company is the one which developed the I2C bus, and it is one of the leading companies in the embedded systems or semiconductors sector. So moving on, which of the following serial communication and parallel communication is not efficient? And here we're tackling it from the perspective of not efficient. Which of these two should not be used for communication using Arduino/Atmega based microcontrollers, and why? So actually we have serial communication and parallel communication, and as you all know, Atmega microcontrollers are actually the microcontrollers being used on the Arduino development boards. So which of these two is not efficient as a communication bus to be used on Arduino boards or Atmega microcontrollers? The serial communication actually sends data bit by bit. However, the parallel communication sends the data all at a time. In serial communication, we need one line or one wire in order to send the data bit by bit. However, in parallel communication, I need multiple lines in order to send the data all at a time, or multiple wires. Okay, so for example, if I want to send 1 byte, which consists of 8 bits, in serial communication, I will be transmitting bit by bit. So each bit out of the 8 bits will be transmitted at a time. However, in parallel communication, I will connect 8 lines or 8 wires in order to send all 8 bits at the same particular moment or time. So here, which of these two is not efficient to be used on Arduino and Atmega microcontrollers? It is the parallel communication, because it uses many wires and it needs complex synchronization. As you can see, if I want to send 1 byte at a time in parallel communication, I will connect to 8 wires, which actually uses a lot of lines or uses a lot of wires, which means it will use a lot of pins. Remember, the Arduino Uno board and the Atmega 328P microcontroller, as you all know from the midterm exam, that actually the Arduino Uno board does not effectively use all of the Atmega 328P pins. Okay, it only uses 8 from port D, 6 from port C, and actually 6 from port B, instead of using 7. Or actually, instead of using 8 from port D, 8 from port B, and 7 from port C, it uses 8 from port D, it uses 6 from port B, and it uses 6 from port C. So just imagine if I want to actually transmit an entire byte at a time. So I will use, for example, the 8 pins of port D just for the purpose of what? Transmitting data parallelly. So actually I used 8 pins, which is a lot. Now I'm left with what? I'm left with 16 effective, with 12 effective pins on the Arduino Uno board. It will be useless to connect other sensors and actuators. So actually, parallel communication is not good for Arduino or Atmega because it uses many lines or many wires. It uses many pins. Okay, plus it needs complex synchronization, because imagine if I'm sending 8 bits at a time. Now I need to make sure that all 8 bits will arrive at the same particular moment, and I will need to make sure that a bit will not actually arrive faster than the other bit, or actually later than the other bits. So we need to actually maintain synchronization in parallel communication, which is hard because you're dealing with multiple bits at a time. However, serial communication is a better option, and you will see while implementing your project that actually most of the sensors may be connected using serial communication buses, whether it's a protocol software defined or using the UART, which is hardware implemented. Okay, software protocols, you will see in the project that they will be using the I2C and the SPI, or you will be using the UART hardware implementation. So finally, as you can see, that you should not use parallel communication. It is better to use serial communication. And I'm pretty sure for your project regarding the touch screen, which is an example, The touch screen uses the entire or uses a lot of pins on the Arduino Uno board, and you are left with very few pins. So you cannot actually implement the entire project on an Arduino Uno. Therefore, you need an Arduino Mega alongside the Arduino Uno, and you will be using the I2C or the two-wire interface, the other name for the I2C being used on the Arduino boards or the Atmega microcontrollers, to actually let the Arduino Uno communicate with the Arduino Mega for your project. However, just a recap for this question, you should not use parallel communication because it uses a lot of wires or a lot of pins. Plus, you have a lot of complexities regarding synchronization, making sure that all bits arrive at the same time, not actually having any delays, a bit arriving before another bit, so it will cause confusion, etc. Plus, as I told you, and as you all knew from your midterm exam, actually parallel communication will not be efficient because it will use a lot of pins, and we do not have the luxury of using actually a lot of pins on the Arduino Uno because we need each and every pin for other sensors and actuators to be connected. So we use serial communication buses compared to parallel communication on Arduino and Atmega based microcontrollers. Moving on, what are the two lines of the I2C and what are they used for? As I told you in the recap, we have the serial data, SDA, which is being used for transmitting data on the bus, and the SCL, which is the serial clock. It's a reference clock for the transfer of data. Therefore, our data or the output will always be synchronous, okay? Because we have a clock that actually maintains the synchronicity of the system or the bus. So SDA for data and SCL for clock. When does the slave selection happen and by what entity? So actually, if I want to, the master wants to request data from a slave, how can the master select a particular slave? This is actually done in the very first byte sent by the master. So you need to actually refer to the lecture to understand the data frames being sent or the frames being sent by the master on the SDA. You'll find out that the very first byte in the frame represents what? Represents the address of the slave. So actually, if the master wants to request data or transmit data to a slave or request data from a slave, the very first byte will actually have the slave address. So here, the slaves are connected to the bus using addresses, and each slave has a unique address that can be addressed by the master. So if the master wants to request data from a slave, it will request it using the address of this slave, which is sent in the very first byte. And you need to refer to the lecture to understand the first byte and the remaining bytes in the frame. Moving on to the second part of our tutorial, which is the two-wire interface, TWI, which is another name for the I2C. So actually, Atmega microcontrollers implement I2C, the same exact concept of having two wires, the SDA and the SCL. However, they call it a different name. They do not use the I2C name, they call it the two-wire interface, which makes sense because actually we have two wires, serial data and serial clock. So actually do not get confused. TWI is I2C, but it is a different naming used by the Atmega microcontrollers. So here, our first question in the second part, in this exercise, you will be setting up two Arduinos to communicate using the I2C protocol. As I told you, I2C is what? It's a protocol, software defined, not a hardware implementation like the UART. So we want to actually communicate or let two Arduinos communicate together. We will definitely use serial communication buses, not parallel communication, as stated in the previous part. And here, first take input from a push button switch on the first Arduino, send the signal received from the button to the second slave, and actually the slave address will be 5, and use the slave to turn on an LED once the appropriate signal is received. So I have two Arduinos, okay? An Arduino that has or connected to a push button, and another Arduino which is connected to an LED or a LED. If I click on the push button on the first Arduino, I want to turn on the LED on the second Arduino. So I need to create what? Some sort of communication between the two Arduinos. Each Arduino will have its code uploaded on the board. Okay, so we have two separate codes. A code will be implemented for the first Arduino, and a code will be implemented for the second Arduino, which are different. The slave should serially print out hello perpetually on the serial monitor every 500 milliseconds. So actually the slave, which is the second Arduino, its main function is actually every 500 milliseconds it prints out hello on the serial monitor. Okay, and I'm pretty sure you should now by this tutorial understand what is the serial monitor and the serial communication being used to actually display data on the serial monitor of the Arduino IDE. And how does actually the Arduino board communicate with the serial monitor of the IDE on your laptop or PC? So again, we have two Arduinos, a master Arduino and a slave Arduino. The master Arduino, which is the first Arduino, is connected to a button, and the slave Arduino is connected to a LED, which is the second Arduino. When I click on the button on the master Arduino, I want to turn on the LED on the slave Arduino. However, the slave Arduino has a totally different function too, which is printing hello on the serial monitor every 500 milliseconds. So regardless of pushing the button or not, the second Arduino, which is the slave Arduino, will always print hello every 500 milliseconds. However, if I push the button on the first Arduino, I want the LED on the second Arduino to light up or to turn on. So actually, this is a schematic of the connection. If I have two Arduinos and I want to connect them using the two-wire interface or I2C, we connect, if it is an UNO model, we connect the A4 pin to the A4 pin of the second Arduino and the A5 pin to the A5 pin of the second Arduino, and both Arduinos should be connected using a common ground. So actually, we have the two main wires or the two main lines of the two-wire interface or the I2C, which will be the A4 and the A5, representing the SDA and the SCL, and it is a convention. So for Arduino Unos, SDA and SCL are A4 and A5, not any other two pins. Okay, it is defined for this or for these two specific pins. They have other functionalities which are SDA and SCL. Okay, so connect for the Arduino Uno, we connect the A4 from the first Arduino to the A4 of the second Arduino. As you can see, the blue line here, it is analog 4 because this is the analog pins, as it is written here, analog in. You can see it analog in from 0 to 5. So here are the analog pins. One of the functions of the analog pins, which is A4, is to be the SDA line. It is defined like this. So I'm connecting line 4 here to line 4 in the second board, and we have the SCL, which is the green line from pin A5 to pin A5. So I connected the SDA of the first Arduino to the SDA of the second Arduino, and the SCL of the first Arduino to the SCL of the second Arduino, creating what? A common SDA and SCL lines. A4 to A4 and A5 to A5. These exact two pins, not any other pins on the board. Also, we must have a common ground between the two boards. It is in the implementation. Therefore, we connected the ground of the first Arduino to the ground of the second Arduino. However, in the Arduino Mega board, we have different pins. We have an SDA and an SCL pins, and they are named on the board SDA and SCL. So if I'm communicating between two Arduino Megas, I will be connecting the SDA to the SDA and the SCL to the SCL. They are named SDA and SCL, not any other names. Okay, and definitely will be having a common ground between both Arduino boards. And yes, you can connect an Arduino Uno to an Arduino Mega, no problem. But however, the SDA of the Arduino Uno will be A4 connected to the SDA of the Arduino Mega, which is pin SDA. And the SCL of the Arduino Uno, which is pin A5, will be connected to the SCL of the Arduino Mega, which is what? Which is SCL, called SCL. Okay? So do not get confused. SDA and SCL on Arduino Uno on the development board are called A4 and A5. However, on the Arduino Mega, they are called SDA and SCL, written on the board as SDA and SCL. However, on the Arduino Uno, they are not written SDA and SCL. They are written A4 and A5. So moving on to our first question, what library should you include in your code? We must include the wire.h or wire.h library. This is the library that uses or implements the I2C protocol or the two-wire interface protocol. It is what? It is wire.h. Therefore, we told you what? That it is implemented also from a software level, because we have this library that actually manages the entire communication. So we need to include it at the beginning of our code. Okay, it is not automatically included like the avr/io.h when we used the register names in the previous tutorials. No, here I need to explicitly include it on my code, or else I will have errors. So here it asks us implement the master part and test it with the other group. So actually on campus, if this tutorial was given on campus, we should have multiple groups implementing the master code, other groups implementing the slave code, and we'll try to connect the two boards together, or the two groups together. However, since it is an online tutorial, we'll be implementing everything virtually. So let's start with the implementation of the master code. And let's recap, or let's actually remember what is the functionality of the master. The master will have a button connected to it. When I press on the button, I need to send a signal to the second Arduino, the slave Arduino, to light or turn on a LED. Okay, so I need to implement this. So if we open our Arduino IDE, which has the setup and loop functions, and as you remember, the setup function is only executed once at the beginning of the code. However, the loop function is our main function, which will execute forever. Okay, so actually you put initializations in the setup function, and then the main code or the main logic inside the loop function. And this is written in Arduino C. Okay, because there is a difference between Arduino C and embedded C. In Arduino C, you can write Arduino C and embedded C. However, in embedded C, you cannot write Arduino C syntax. So if you are actually writing a code on the Arduino IDE using Arduino C, you can use embedded C syntax. It is accepted. However, if you are writing a code using embedded C on a different IDE, you cannot actually use the Arduino C syntax. And here we do not have a main function, so we will not write embedded C. However, you can write embedded C inside the setup or the loop. The syntax of embedded C can be written. However, you can actually use Arduino C. Like for example, if I want to set up the direction of pins, Arduino C, we use pin mode, if you remember, or actually if you may not remember, but this is Arduino C. I could say pin mode, actually pin number 13, and I want it as an output. Okay, so actually pin number 13 is now an output. Okay, and pin number 13, this number is the number written on the Arduino board. It is not of the Atmega microcontroller. I do not know pin 13 actually maps to which port and to which pin inside the port. You need to refer to the data sheet, always refer to the data sheet, to actually know the mapping that pin 13 maps to which port and which pin inside the Atmega. However, this number, the 13 number, is actually the number present on the Arduino board. Like when we actually, if we go back to our slides, here, pin 13 is actually this one, as you can see my cursor. Okay, this is the number 13. So actually, I want this particular pin to be an output pin, for example. However, I do not know this pin, whether it maps to which port, BCD, if we are an UNO, and actually which pin inside the port. Okay, we need to actually refer to the data sheet of the Arduino, not the Atmega. We need to refer to the documentation of the Arduino Uno board to know which port and pin does this location map to. So going back, okay, I could actually find out from the Arduino documentation that physical pin 13 is port B pin number 5. Okay, so port B pin number 5 is actually digital pin 13 on the Arduino Uno board. So instead of writing pin mode 13 comma output, which is in Arduino C, if I want to do it in embedded C, I was going to write DDRB equal to DDRB ORed with 0, 0, 1, 0, then 0, 0, 0, 0. Okay, because this is bit number 5. Okay, actually, the Arduino IDE will not complain about this line. So actually, using Arduino C, I could set port B5 as an output using pin mode 13 comma output, or I could write DDRB or equal, and then I need definitely here to write what? To write 0B. Do not forget to actually inform the IDE that this is written in binary, not in decimal. So actually here I'm also setting port B5 as an output, but using embedded C. In the above line, it is using what? This is Arduino C, and here this is embedded C. And actually on Arduino C, you can write embedded C. But there are definitely higher level functions like the pin mode that make your life easier, because you do not need to know actually which port and which pin inside the port does the particular physical port on the Arduino Uno map to. I do not know pin 13 maps to which port unless I open the documentation. But actually, I know that it is 13 written on the Arduino board. Therefore, it is easier to use the Arduino C functions because they use the numbers on the board, not the actual mapping, whether it is port B or port C or port D. Okay, so actually let's go back to our question. I just wanted to show you this because a lot of people made it wrong in the midterm exam. So let's actually create or write the master code. The master code in the setup, before even writing anything, inside the setup, I need to what? I need to include the wire.h library. Okay, and wire is capital W, and you will find it in orange. Okay, so I need to include the wire.h library in order to use the two-wire interface functions or the I2C functions in the code. Second of all, we could actually create global variables. For example, int tx command equal 0, and by the way, tx stands for transmit, rx stands for receive. Okay, these are abbreviations, well-known abbreviations in programming. tx transmit, rx is receive. We actually created a variable called transmit command, and this variable, the value inside it will be transmitted to the second board. So actually it will contain the signal, or it is the variable that will signal the other board. I will send the data of this variable to the second board, whether it is 0, the button is not pushed, or 1, the button is pushed. Okay, so this will be the variable that I will be sending to the other Arduino board. Then I could have actually the slave address, int slave address equal 5, because the question told us that the second slave must have an address of 5. So actually I created a variable containing the slave address, which is 5. I could actually command the code data to be transmitted to slave, and here what? Here the slave address, here library to implement or to use I2C, slash two-wire interface. Okay, then we could have a variable called button state equal 0, and this will actually what? Contains the value of the button. Because as you all know, normally if a button is not pressed, it will be 0. If it is pressed, it will be 1. So actually I will read the button value and store it in this variable, which is button state. Button state is a variable used to store the state or the status of the button. When I read the value of the button from the pin that the button is connected to, I need to what? I need to actually store it in a location, so I'm storing it in this variable. Also, I need to actually say const int button pin equal to. Here, I connected my button to pin 2 on the board. So actually, I will look to the Arduino board, I will look where is pin 2, and I will connect my button to it. I could connect it to any pin. The question did not specify the pin number. However, I connected it to pin 2. I could connect it to pin 10, pin 12, whatever pin. Okay? Pin 13, which is PB5, I could connect it to any pin. However, here I decided that my button will be connected to pin number 2. So I will read the value of pin number 2 using digital read and will perform some comparisons. Here, button is connected to pin 2 on the Arduino board, and I do not know whether pin 2 maps to which port. I do not care because I am writing in Arduino C. Now let's move on to the setup. Here, I want to set the direction of my pin that is actually connected to the button as an input. So using pin mode, I will not use DDR. I will say button pin, which is 2, and input. Now I configured the direction of pin number 2 as an input pin. So I will be reading its value. This is equivalent, like for example, using the DDR and masking this bit to 0. Okay, but since we are using Arduino C, pin mode is much better, and I do not want to open the documentation and check pin 2 is connected to which port and which pin inside the port. Okay, so actually we use Arduino C functions, which are very simple. Okay, now what? Now the direction of my pin number 2 is set as an input pin, so I can read the value of the button. Now we want to actually join the bus as a master. How do we join the I to C bus as a master? I write wire dot begin without actually what? Sorry, wire dot begin without actually specifying an address. So if I write wire dot begin, this Arduino board is now connected to the I2C bus as a master. Okay? So now here, join bus as master, and here setting what? Direction of pin 2 to input. Okay? Now this Arduino board, the first board, is now connected to the bus as a master. We actually perform the physical wiring. As I told you, we connect A4 to A4 and A5 to A5, or SDA to SDA and SCL to SCL, or A4 to SDA and A5 to SCL, depending on the Arduino model. And now this Arduino board is connected or joined the bus as a master. We need to write the code. So what will be the code? I will go into the loop function to actually start implementation. First of all, I want to read the state of the button. Is the button pushed or not pushed? So I have the variable which is called button state will be equal to digital read, and I want to read from which pin? Button pin. Okay, so here what? Read value of pin 2, which is button. Okay, so here what I'm doing is that I'm using digital read, which is equivalent to reading the pin register, but here we are writing in Arduino C, not embedded C. So digital read, I want to read the value of pin number 2. It will be 0 if the button is not pushed. It will be 1 if the button is pushed. Following on, I need to check if actually button state is equal to high, equal to high meaning equal to 1. Low is 0, high is 1. If it is equal to high, I want to make the tx command equal 1, else the tx command is equal to 0. Okay, the tx command is the variable that will be transmitting to the slave. Okay, to actually signal whether we want to light up or turn on the LED on the slave Arduino. So here we are writing what? The master code. Here, this code will be uploaded to the first Arduino board. So it will only contain the master code. Here, we will check if the button static will equal high, which means it is pressed, what? Transmit 1 to slave. Here what? It will transmit 0 to slave. Okay? tx command equal 1 and tx command equal 0 is not actually transmitting, but actually value to be transmitted. Let's make it accurate. Value to be transmitted. And here, value to be transmitted. Value to be transmitted. Okay? So here, if I'm clicked or I actually pressed on the button, it will be high, which is 1. So I need to send a 1 to the slave Arduino. If it is not, I need to send a 0 to the slave Arduino. Okay, then after I'm done here, I want to send to the slave Arduino. How does a master send? It will send as follows. We use wire.begin transmission, and actually mission is double S. Okay, and then we put what? We send the slave address. So here, what? We specify slave address. Okay, so wire.begin transmission, I want to transmit data to a particular slave on the bus. The first thing is using the begin transmission function, we specify the slave address, which is here 5, which is stored in the slave address variable we created initially. Okay, then I will send what? Wire.write, and I will write the tx, or will send the tx command variable. So what? Transmit the signal. So tx command is the variable containing our signal 1 or 0. I want to transmit this value to the slave. Okay, then after this, what will happen? I need to end the communication. So wire.end transmission. Transmission. Okay, and we actually create here. We hear what? End transmission to slave. Okay, then we can create just a delay for 200 milliseconds just for everything to settle up. Okay, so this delay is just to make everything settled up, not to send continuous. Just a simple delay, 200 milliseconds. It will not actually affect us. It is just a simple delay. Okay, nevertheless, what did I do here? Word.begin transmission. I specified the address of the slave I want to send to the data or transmit the data to. Then wire.write, I actually insert as a parameter the data that I want to transmit, and this data is actually stored in a variable called tx command. And then after I send it, I need to end the transmission, wire.end transmission, because actually if a master is controlling the SDA, no other master can use the SDA line. So this master, when it finishes sending, it needs to end transmission. So if there is another master that wants to actually communicate with another slave or the same slave, whatever, it can access the line. Okay, so we need here to end the transmission. Okay, so begin transmission, write, and end transmission. I am done. I will control S and I will do what? And I will upload this code to the Arduino board. As you can see, we have here verify and we have here upload. But since I'm not connected to an Arduino board, so it will not actually upload. Verify is equivalent to compile, and then we click on to upload, or we click upload to actually upload it to the Arduino board. Okay, so this will be the master code. Now, the second part asks us to actually implement the slave code. So if we go back here, this is the same code. Here, implement the slave part and test it with the other group. So we wrote the master code, and now the master can transmit data to the slave. Now we need to see the reaction of the slave, the second Arduino, and what type of commands or functions will be present inside the slave. So moving on to our Arduino IDE, this is a new sketch, a new file. This file will be uploaded to the second Arduino, which is the slave Arduino. At the beginning, we definitely need to include our library, which is include wire with capital W .h, so we can actually use the I2C /TWI functions. Then let's assume that our LED will be connected to pin 13 on the board. So I need to create a variable called LED equals 13, and then we will have a variable called int rx command equals 0. Okay, the rx command will be the value received from the master or received from the I2C bus. Okay, so actually I had in the master code the tx command, the transmit command, which is actually the data that will be transmitted on the bus. Here, the rx command is the receive command, the data that the slave received from the bus. It needs to actually put it in a variable. So here, data to be received from master, and here what? The LED connected to pin 13, which is equivalent to port B pin number 5, as I told you if you open the Arduino documentation. Okay, so here at the beginning in the setup function, which will only execute for once at the beginning of the code, then the loop will take on forever. I need to set up or configure my LED as an output pin. So using pin mode, I will say LED comma output. Here, pin 13 is defined as output pin. Then moving on, I need to actually, since the slave, one of its functionalities, regardless of the master commands or the master signal, is to print hello every 500 milliseconds. Okay, so I need to print hello every 500 milliseconds, regardless of the data being transmitted by the master. This is the functionality of the slave Arduino. Okay, it is not related actually to the data being transmitted on the bus by the slave. It's just a different functionality that is performed by this particular embedded system. So in order to print something on the serial monitor, we need to actually write serial.begin, and definitely S must be capital, serial.begin 9600 here to use the serial monitor. Okay, as I told you, serial.begin is actually, it's a serial communication. It uses 9600. This is the baud rate. The baud rate is 9600 bits per second. Okay, it's like a rate, a convention rate that actually two systems can communicate with. So in order for the Arduino board, the second Arduino, the slave one, to actually access the monitor of my laptop. My laptop is a device and the Arduino board is a totally different device. Okay, they are connected serially using the USB. And as we all know, USB uses serial communication. Okay, so actually here they agreed to communicate on 9600 in order for the Arduino board, the slave board, to actually print something on the serial monitor. And this is the serial monitor link. Okay, definitely I cannot open it now because I'm not connected to an Arduino board. However, if you open it and you click on the serial monitor, you can choose one of the rates, and we choose 9600, and every 500 milliseconds the Arduino Uno board, the slave board, will actually send hello to my laptop to be printed or displayed on the serial monitor. So actually serial.begin 9600 just what to use the serial monitor on my laptop. Okay, now we want to actually join the I2C bus or the two-wire interface bus as a slave. So here we use wire.begin like the master. However, we specify here the address. Okay, join bus as slave with address 5. So the difference between the master and the slave, the master joins or uses wire.begin without specifying an address. However, the slave must specify an address when it calls wire.begin. So here, wire.begin 5, we joined the bus as a slave with address 5. And we also need to actually use a function called wire.onReceive, and it will receive an event. Okay, so actually we attach, or we can actually write some comment for this. It is attach a function to trigger when something is received. So as I told you, the slave board has a main functionality that will be implemented inside the loop function, which is what? Which is printing hello every 500 milliseconds on the serial monitor of my laptop. Okay, so every 500 milliseconds, the Arduino slave board will send hello to my laptop to print it, a hello text to be displayed. However, I will attach a function, and this function is called onReceive, that will receive an event. Wire onReceive means what? That if the master decides at any time to send me data, this will trigger this function. So this function, the onReceive, will only be triggered when the master transmits data and specifies my address as what? As the recipient address. Okay, so here, before actually writing or implementing the loop, I need to implement a void function that I will call it receive event. So this receive event is the name of the function that I will implement. So actually wire.onReceive means that if my address was specified by a master and the master is transmitting to me data, I will take this data as an input and call the function which is here, I called it receive event. Okay, and we know that it will receive bytes, so int bytes. Okay, and then we can implement it. Okay, rx command is equal to wire.read. So here what? I read the input from the master. Okay, so actually the master decided to transmit me some data. Wire onReceive will actually see that the master is addressing me. So it will let the slave call the receive event, or it will actually call a function called receive event, which I implemented here, which takes as an input parameter an integer, which will be the signal transmitted by the master. Rx command is the variable that I created in order to store the value that is being received by what? By the master. Wire.read, I will read this data. Okay, so here I'm reading what? I read one character from the I2C bus. Okay, and since this is a high level implementation, the wire.read reads a character. A character is 8 bits, so it is what? It's a byte. So actually the wire.read receives a byte, or actually will give you a byte. Okay, and we'll store it in the rx command. We know I2C sends bit by bit. However, this library, the wire library, will actually combine the 8 bits into a byte and will give you the entire byte, because normally you send bytes, you do not actually care about bits, but the byte will be transmitted bit by bit. So it will be transmitted bit by bit and then collected by the wire library and will be presented to you as a byte. Okay, so yes, because someone will tell me why here I'm reading one character which is a byte, which is 8 bits, and actually I'm transmitting bit by bit. So I transmitted a byte by the master. This byte will be actually divided into bits and will be sent bit by bit, and at the slave side, each bit or all of the bits will be rearranged again or combined again to form the byte. Okay, so I do not actually dig into the details or the implementation of how do I actually divide the byte into bits and send them over the I2C bus and then collect the 8 bits again and form the byte. It's not of my business. Okay, it's not in my business. The wire library handles all of these issues. Okay, I just wire.read just receives a byte. Okay, it actually collects all bits and forms the byte again. Then I will see if rx command is equal to 0. So what shall I do? Digital write LED low, else digital write LED high. So actually I will receive a byte from the master saved in the rx command variable. I'm going to check on its value. If this value is equal to 0, it means the button is not pushed, therefore the latch should remain off or should turn off. If the rx command is 1, meaning that the button was pushed on the master side, then I need to what? I need to write high. I need to turn on the LED. Okay, so I digital write LED high. Here, turn on LED. Here, turn off LED. So as you can see, according to the received byte, I'm going to actually turn on or turn off the LED. And this signal is actually stored in the receive or Rx command. Okay, so again, recapping this section, Rx command equal wire.read, I read an entire byte from the master, and we do not actually take into consideration the details how the 8 bits are actually combined again to form a byte. It is done through the wire.h library. However, from an end user perspective, I receive a byte. Technical details, it is sent bit by bit, or it is sent bit by bit. Okay, but it is formed again at the slave side and is formed again as a byte. I'm going to check. Here it is not equal. Here it should be equal to 0. If Rx command equal to 0 means the button was not pressed from or on the master side, so I will not turn on the LED. However, if it is pressed, which means it was 1, it is the else part of this code, then I need to turn on the LED. Okay? Moving on, we need to write what? We need to implement the loop side. Okay? And the loop side will be different because here I have a loop and I have a function for the slave, regardless of what? Of receiving any event from the master. This is what is serial.println hello. And I actually can write it like /n and then delay 500. Okay, so here serial.println hello, I will be printing hello on the serial monitor, and delay 500, I want to print it every 500 milliseconds. This is implemented inside the loop. This is the concept of perpetually. Okay, I will constantly print hello on the serial monitor every 500 milliseconds, regardless of the state of the button, whether it is pushed or not. This is the main functionality of the slave, is to print hello on the serial monitor. However, if the button on the master side is pushed, I need to turn a LED, which is connected to the slave. Therefore, if the master decides to transmit to me some data, which is wire.onReceive, will actually take into consideration that the master specified the slave address, so the wire.onReceive will notify the slave and tell the slave that you need to execute this function, which we call the receive event. So void receive event, it takes as an input the byte that will be sent or will be received, and Rx command equal wire.read, read one character from the I2C bus, meaning that actually I will receive it character by character or byte by byte. However, as I told you, we do not take into consideration the implementation details, how bits are actually sent on the line bit by bit and then reformed again at the slave side. We do not care. We'll just receive it as an entire byte, and we will check on this byte. Someone will ask me, why does the receive event take an input parameter called in bytes and we are not using it? It is just the signature of this function. Okay, yes, we are not using actually int bytes, because someone will tell me we are actually getting the byte from the wire.read directly. Why do I have an input parameter for this function? I will tell you it is just the signature of this function. It must take an input. Okay, it's very simple. So overall, we had the master code, which transmitted the value or the state of the button, and we had the slave code, which actually reacts according to the value received from the master. Each one of them is uploaded to a different board. The master code is deployed on an Arduino board. The slave code is deployed into a totally different Arduino board. Both are connected using I2C physical wires, I2C, the SDA to the SDA, the SCL to the SCL, and a common ground between both. However, the wire.h is the library that makes sure that everything is implemented correctly. Okay, and everything is actually working according to the I2C or the two-wire interface protocol. Now let's move on to our third and final question. So here in this challenge, the master should verify a 6-character password entered serially by the user on the slave side. So here we have two Arduinos, a master and a slave, connected together using the I2C or the TWI, two-wire interface together. So the SDA is connected to the SDA, the SCL is connected to the SCL, and we have a common ground between both Arduinos. Here on the slave side, using the serial monitor, the user will input a password. Yes, using the serial monitor, you can input or you can output. You can have something printed on the serial monitor, or you can actually input text on the serial monitor. It's like the console of Eclipse. You have items printed on the console, or if you used the scanner in Java, you write in the console as an input. The serial monitor acts exactly the same. So on the slave side, a user will write a password, a 6-character password. This password will be sent to the master to verify it if it is correct or not. And later on, the master should print out serially. Serially means using the serial monitor if the password is correct or not. So after verifying the password, the master on its serial monitor will print whether the password is correct or not. So let's go into the implementation using the Arduino IDE. The master code, which will be uploaded on the master Arduino board. The first thing, as you all know, we need to include the wire.h. However, as you all know, or as you all seen in the previous question, the serial.h is automatically implemented or automatically imported or included. When I used serial.begin 9600, I did not actually I did not include serial.h because it is automatically included like avr/io.h. These are libraries that are automatically included by the Arduino IDE. However, the wire.h is not automatically included by the Arduino IDE. So here we are in the master code. We will have a string called password, and initially it will be empty. So storing the received password, I need to actually store the password transmitted from the slave. Now I know some of you will be asking me, how can a slave send to a master? We will see how can a slave send to a master. But let's move on. String password, then here we have the setup function. We need to start wire.begin joining the I2C bus as what? As a master. I do not specify an address as an input parameter to the begin function of the wire library because I'm joining what? I'm join as a master. Okay, then I will use serial.begin 9600 and actually what? To use the serial monitor as if I am initiating a communication between my laptop and the Arduino board using the USB cable, which is a serial cable. So we use the serial library. So I can use the serial monitor in order to print whether the password is correct or not. 9600, as I told you, it is the baud rate, BAUD, which is the bits per second being transmitted. And by now, you should know that serial.begin is a function for using UART, okay, which is a serial communication hardware implemented inside the ATmegas. So actually, serial.begin uses UART, wire.begin uses I2C. You should know this from the previous tutorial that serial.begin initiates a communication using UART. I did not actually state it in the previous question, just to see if you guys actually watched the previous tutorial. However, I could say it since this is the last question in this tutorial. Serial.begin, actually now we are using UART. So we are using two different serial communication buses, the I2C to receive the password from the slave and the UART to actually what? To display whether the password is correct or not on the serial monitor. Okay, so the serial monitor is part of the UART. Apparently, it uses UART to communicate between the laptop and multiple Arduino boards. However, since some people will ask what is the line or the wire connecting the laptop with the Arduino board, it is the USB cable. Okay, and the USB cable uses what? Uses UART. Okay, so this is serial.begin is UART, and here it is I2C/TWI. All right, so moving on, here I actually decided 9600 bits per second, the speed of transmission. We can go into the loop. Now, the main function is how can actually a slave send data to the master? However, the master is in control of the line. Here it is. The master actually requests from the slave to send or transmit data back to the master. So actually the slave alone cannot transmit data on the line or on the wire. The slave cannot transmit from its own. It needs to receive a request from a master. And here we need to actually write the request. So we use wire.on or wire.request from. I'm requesting from. The first parameter is the address and the second parameter is the length. So 5 equal address of slave and 6 equal length of data. Okay, 6 bits here. Or I mean 6 bytes. It is 6 bytes, length of data in bytes. Okay, because we'll be sending 6 characters. Each character is 1 byte. So here we specify the length of the data using bytes. So wire.request from. I am requesting from slave number 5, which is the first parameter, to send me 6 bytes of data. Okay, so actually the master controls which slave will send on the line or will transmit on the line or on the bus, and the size of the data being transmitted. So as you can see, the master is in full control. Slave 5 will only send 6 bytes, and 6 is bytes. Okay, then we'll be doing what? While wire.available, and by the way, wire.available means that there are actually data being transmitted on the wire, on the bus, I mean. We can have a variable called char c equal to wire.read. So here I'm actually wire.available means that as long as there is data in the buffer, because I'm sending 6 bytes, okay, so it will be stored in a buffer. Wire.available accesses the buffer. Here what I could say, as long as there is data in the buffer, okay, so the slave will be sending me bytes, and these bytes will be stored in a buffer. Okay, and actually the master will read using the typical wire.read byte by byte. Here I want receive a byte as a character. And take care, because actually the bytes are received here as characters. Okay, so we store it in a char variable. That's the convention of the wire. Okay, it stores the data being received as chars, not as ints or anything else, or as bytes. It is stored as chars because one char is equal to 1 byte, which is 8 bits. So actually they store it in chars. Okay, nevertheless, we do not care about actually why does the wire.read return chars or characters, not integers. It's not of our business. Okay, so it receives a byte as a character. Now I need to do what? I need to concatenate password is equal to password plus C. Okay, as you remember, we had the password variable which will store our password. Here we do what? Here we perform a concatenation. I will receive a byte and put it in what? And concatenate it in the password string. Then I receive the second byte and I will concatenate it to the password string. The third byte I will receive it and concatenate it in the password string, etc. and so on. Okay, so here I receive a byte as a character, and here I concatenate it in the password string, so I can have a 6-byte password or a 6-character password, because I need to concatenate the 6 bytes together using a variable called password. Everything is fine. Now we here, after we finish this while loop, we want to check on our password. If password is equal to whatever the password we want to check for, just we want a 6-character password. So let's have it my name is 5 characters. Okay, Walid 5, for example. If it is equal to Walid 5, this means what? That I will print serial.println password is correct. Okay? Else or not else. Just let's keep it like this. Here I'm checking on the password that it is correct. Okay, so if password equal to Walid 5, I decided that my password will be Walid 5. If it is actually equal to Walid 5, then I will print on the serial monitor password is correct. Printing on the serial monitor. Yeah, actually we are using here serial.println, so I do not need to use /n, which I used in the previous question. Or yeah, because here it is serial.println normally. Okay. However, I need to what? I need to reset this. So if password dot length is equal to 6, I need to say password is equal to empty. Resetting the password variable to start taking a new 6-character password from the slave. So here we had something that if my length is equal to 6, so actually I checked, okay? If it is equal to 6, what shall I do? I should actually reset the password variable because it is done. I entered the password. So the password variable must be cleared, must be empty, because if the user entered a wrong password, now I'm expecting that the user will send me another 6-character password. So I will not concatenate the new 6-character password with the old 6-character password. I need to clear or reset the variable. So if actually my length is equal 6, so if the user input 6 characters, what shall I do? I will reset the variable, meaning that the first actually attempt was done, okay? And now I'm waiting for a second attempt by the user. That's why here I am clearing the password. However, above, if the password is equal to Walid, I print password is correct. I could have an else part saying that the password is incorrect. Okay, so yeah, you could have here an else part saying password is not correct. Okay. However, it looks like the question did not ask for an else part, or maybe it asked for an else part. It does not matter. However, if the password wanted only, or the question wanted only to print that the password is correct, not correct / incorrect, then you do this. If it told you to print the password is correct or incorrect, so you could have an else part saying serial.println password is not correct. It's very simple. Okay, printing on what? Printing on the serial monitor. All right, and definitely here we could actually create some sort of delay, for example 500 milliseconds, just to make sure that everything will settle and be configured instead of what? Rushing out. Just 500 milliseconds to make everything be configured correctly or settled correctly. Okay, so here we received the password, or we asked slave number 5 to send me 6 characters. As long as I have characters available in the buffer, I will read each character and concatenate it to the password variable. Then I'm going to check if the password is equal to the password that I want to compare with. I will print on the serial monitor it is correct, else I will print it is not correct. And when the length is actually equal to 6, I will reset the variable. However, maybe we may not need an else part here, because if the user entered 5 characters and it took or maybe the user actually did not finish sending all characters on time, it may say that the password is incorrect. However, the user only, for example, entered 5 characters out of the 6. Okay, because if the wire because actually take care, these are 2 different Arduino boards. Okay, this is inside the loop of the master board. So actually, if the slave is sending 6 characters, however, the slave sent only 5 or 4 characters, the other Arduino board will actually continue looping. So here, it will print, it is not correct. For example, if I send 5 characters, which are Walid, and I did not send the 5, there was some delay, or actually I was doing something else, then I will actually type the 6th character. It will actually say that the password is incorrect if not all 6 characters are actually inputted at the same particular moment, okay, from the slave side. Therefore, it will be a bit risky, so we can remove actually the else part. Okay, either print password is correct or do not print anything else. I mean, can you see my point of view that I'm receiving from a totally different Arduino? Who told me that I will receive all 6 characters at the same time? Maybe I'm entering a character, then I will take 2 minutes and enter the second character. However, I need to check on the 6 characters as a whole. Therefore, the first Arduino, which is the master, is in an infinite loop, or on an infinite loop, meaning that if the password is not equal to Walid 5, if it is equal to Walid without the 5 because the user did not enter the 5 character yet, or character 5 yet, what will happen? It will print that the password is incorrect. However, it is not incorrect, it is incomplete, because the length is not equal to 6. Therefore, there is one missing character the user may input after 2 minutes, after 3 minutes. I do not know. The user is actually inputting on a totally different computer using a totally different Arduino. However, both Arduinos are connected together. But I have my PC with a serial monitor, and the user has their own PC with their own serial monitor that they are inputting on. We are not sharing serial monitors. Okay, we are not sharing laptops, we are not sharing Arduino boards. Therefore, here, if the password length equal 6, I will reset it. If it is not equal 6, I may wait, because actually the user may enter another character, which will make it up to 6. And at the same time, as long as the password is not equal to 6, or the length is not equal to 6, I cannot print the password is incorrect. Here, I could have actually added a condition that if the password length is equal to 6, I could perform the password check. Okay, so actually I could have added this here. If it's equal to 6, I may do this, and else serial dot println password is not correct. Okay, now if actually the user prints or I receive all 6 characters, I can check whether the password is correct or not, and later on, or else or not else, then I will reset or clear the password variable. Okay, so if you do not get me here, the problem is that the user may not send all 6 characters after each other. There may be some delays, so I need to make sure that once the password length is equal to 6, the user sent me 6 characters, I can start now checking if the password is correct or not. Therefore, I inserted the checking condition inside the condition of if the password.length is equal to 6. Because here I'm checking on the 6 characters sent by the user. If they are equal to my password, I will print password is correct, else I will not print password is not correct. However, if I only received 1 character, 2 character, and the user is still sending the remaining characters, I cannot say the password is incorrect. I need to have all 6 characters. Therefore, I move this condition inside what? Inside the if password.length equal 6. However, in the practice assignment solution, you will find it is not in the loop. It is not in the if condition, I mean, of the password.length equal 6, because it is not checking if the password is not correct or not. If the password is actually Walid 5, it will just say the password is correct. Otherwise, it will not say the password is incorrect. Okay, so here I'm just saying that this solution is somehow different from the practice assignment solution. However, we can consider both as correct. Now let's move on to the slave code. So actually, I need to move on to the slave code here. Okay, so what shall we do, or what shall we write? As I told you before, the first thing is we need to include the wire.h library so we can use the I2C or the two-wire interface bus. Then here, I need to actually, in the setup, join the bus as a slave. so wire.begin, and here we say 5 because my address will be 5. So joining or writing wire.begin and putting an input parameter, or actually sending a parameter to the begin, means that this parameter is the slave address. Okay, so here joining the I2C bus as a slave with address 5. Then here I will say serial.begin 9600 because I want to input data on the serial monitor. And as you remember, this is UART, while the above is what is I2C. Here we will create a new function, or we'll attach a new trigger called wire.onRequest. Here request, or let's write it small, request event. Okay, here what are we doing? Attaching a function when a request from the master is needed. Okay, so previously we had wire.onReceive and we had a receive event. So actually when the master was sending data to the slave, it was wire.onReceive. The slave was receiving. Here what? Wire.onRequest. The master is requesting data from the slave. Therefore, we'll create a function called request event, not receive event. Because in this situation, the master is requesting data from me as a slave. And as a slave, I need to transmit data on the line or the wire or the bus. Okay? In the loop, I will not write anything. I will just may have a delay of 100 milliseconds for everything to settle. However, here I will create void request event. Okay, this is the function that is attached to this trigger, meaning that on request, when a master requests from me data, it will go and execute the function called request event. Here I will have while serial.available, okay, as long as the user is writing data to the, or inputting data to the serial monitor, is inputting data to the serial monitor. Here serial.available is like wire.available. I have a buffer, but the difference is that serial.available takes the input from the serial monitor. So actually the user is inputting data from the console, which is the serial monitor, writing letters or characters. Okay, so serial.available is the buffer that stores these characters. So as long as the user is inputting characters on the serial monitor, I will have a while loop. What will I do? I will be having in character equal serial.read, read character by character, and what? Wire.write the character. Transmit back to master requesting the data. So what did I do here? Well, serial.available, as long as the user is inputting some characters, int character equals serial.read. Here it is different. The serial.read returns to me an integer. However, the wire.read returns to me a character, a char. It is regarding the implementation of these library functions. Okay, serial.read inputs integers, or actually returns integers. Wire.read returns characters or chars. I do not care why. Okay, this is the implementation of the library functions, but take care because it is tricky. Okay, here I said read character by character, not meaning that it is a character. I mean, yes, it is a character, but actually I'm not reading the entire password at a time. Okay, I'm reading it character by character. Okay, and after I read a character, wire.write character, I will be transmitting this character on the bus. Wire.write character, and I do not need to specify the address of the master. The master does not have an address. The master requested from the slave to transmit. So actually the master reserved the bus for this communication for the slave to transmit back to the master, or send back the requested data to the master. And the master will only accept 6 characters. The master will not accept more than 6 characters. Okay, because when the master, in the master code we use the request from, we actually specified the address and the number of characters to be transmitted by the slave. So wire.write character, I will only be executing this function for 6 times. The 7th will not be accepted. Okay, so int character equals serial.read. We are taking the character input from the serial monitor and then saving it in a variable called character. Then I will be transmitting this variable data or variable value to the bus. Okay, in order for the master to actually receive and perform the verification of the password, whether it is correct or not. So as you can see, always the slave code is simple, but the master code is what is complex, because the master is the one initiating in both scenarios, whether the master is sending or transmitting data like the previous question, or like in this question, the master is actually requesting data from the slave. Okay, and here in this exercise, we actually seen how to use the wire or the two-wire interface, which is I2C, and the UART, which is the hardware physical circuit for serial communication, the UART. However, as I told you, I2C is a software-defined protocol. UART is a hardware-implemented bus. So we've seen how to use actually both together. We used the serial or the UART for the serial monitor to display and to take input, and we used actually the two-wire interface or the I2C to receive data and send data between two Arduinos, having a common bus, which is the I2C bus. Okay, so as you can see, do not get confused between that. Here it is int character, not char character, because serial.read returns integers. However, wire.read returns what? It returned char. So actually, when I tried in the master code, if I here have the master code, receives the data, I received it as char c equal wire.read, because the wire.read returns for me what? Returns for me characters. Now we are done with the tutorial. If you have any question, don't hesitate to post your question on Piazza. Stay safe and goodbye.